Hello, I am Dr. Uksung Kim. In this video, we will be discussing the free body diagram. This slide shows the overview of my lecture. In the beginning, I will talk about the definition of free body diagrams. Then you will learn about the free body diagram for common systems and procedure for drawing a free body diagram. After these slides, I will solve an example problem with detailed explanation. Finally, I will provide a practice problem to check the level of your understanding related to this topic. A free body diagram, it is also called the free body diagram. There's a F, B, D. Is a drawing that shows the particle with all the forces that act on it. Now, I will explain common systems, which are springs, cables and pulleys, and smooth contact. A spring is used to support a particle. The length of the spring will be changed in proportion to the force F acting on it. And then this is the relationship, and then L is that the elongated length, and then LO is that the original length. And then this is a K, that K is called the spring constant or stiffness. A cable can support only a tension or pulling force. So this is a very important system in the cables and pulleys. The tension force developed in a continuous cable which passes over frictionless pulley must have the same magnitude. That means that the T1 and T2 is the same magnitude. Okay, that is the only change the direction. So that is the important thing for this system. Last one is that the smooth contact. If an object rests on a smooth surface, then the surface will exert a force on the object that is normal to the surface at the point of contact. So in addition to the normal force N, there's a normal to the surface. And that the object is also subject to its self-weight, that is the W, and then also the force T from the cord. So this is the free body diagram of this smooth contact, have this kind of the free body diagram. So this slide shows the procedure for drawing a free body diagram. So step 1, draw, outline the shape. The particle needs to be isolated. That is the important thing. You don't need to draw the entire one, just isolated. You are interested to draw the free body diagram. Step 2, show and include all the forces. So active forces tend to set the particle in motion, and reactive forces tend to prevent motion. So there's like some constraint or support. And then step 3, identify each force. That one should be labeled with their proper magnitude and direction. Sometimes the direction is obvious, or sometimes they use the assumed direction. So in this slide, you can see the example problem. So to solve this example problem, we need to draw the free body diagrams at D and the C. So actually, example problem, maybe I will use this one for the other video clips for the equilibrium equations. So that is to determine the tension force. And then TCA, so there's a tension of this cable. And then tension force TCB, and then TDC, and then TDE. So that is the 4 unknown tension forces to find the this one. So to do this, the most important step, first step, is to draw free body diagram. And then at this time, I ask you to draw the free body diagram at D first, not from C. I will explain the later for the other video clip, but just one clue is that just minimize the number of the unknowns. So draw the order of the D and C. So now you can see that each free body diagram has only two unknown tension forces. So I will draw the free body diagram at D. So free body diagram at D first. Okay, in these free body diagrams, and then you can see that, so this one is that the isolated. So that one is about the D, right? So just isolated, right? You don't need to draw the entire system, just at D. And then after that, so there's a cable, so there's only tension able to handle, so there's a pulling forces. So there's a direction is correct in this one. And then that one is pulling down also with the M mass, this one. So there's a actual force is M times G. There's a gravitational acceleration. And then that is the tensile force. So that is the T, D, E, and then that is the T, D, C. So that is the known, but the TDE, TDC, there's a unknowns. And then don't forget in this part of that, you also put the angle. So that is at the 20 degree. So that is the important thing also. So this is the free body diagram at D, okay? So that one is that I mentioned the two unknowns is the two unknowns, the TDC and TDE, right? And then free body diagram SC, same thing, just isolate this one, okay? Don't need to draw the entire system. So you just draw the SC, and then there's a TCD, okay? And then you have also this one and in this one. So there's a TCA, right? So CA, right? And then CA, right? And then TCB, and then C, and then B. And then you know that the previous procedure, we know that the TDC, so actually this one is that the TCD is the same. So that's the reason your unknown is only TCA and TCB. And then there's some missing part because you need to know that the angles. So this one angle, there's a 40 degree over here, right? And then that one, you can see that this is also 40, right? So that means that this one is at the 40 degree, right? And then in this one, for the CA, there's a small triangle is given. So that one is that you draw this one, there is a 4, that is the 3. So you put the angles and then all that kind of the information and then also forces, and then you actually complete your free body diagram. So, and then this slide shows the solution of the free body diagrams. So you can look at this one, the free body diagram at D, and then free body diagram at C, okay? And then in this one, I also using the red color as unknown force tension forces, and then the blue color for the given force or information. So there's angles and the mg, there's a that one is the blue color using this one, there's a given condition. And then TCD is at this stage is given because with this previous step, provided at D, you can find the TDC. And the TDC is the same. You can find the TDC, so TDC is the same as a TCD. But I will explain this one in more detail for another video clip related to the equilibrium equations. So I hope you can draw the free body diagram as D and C. And this slide shows a practice problem. So I will also use this problem for the also equilibrium equations. But in this stage, just try to draw the free body diagram at O. So you need to draw the free body diagram at O. So that is the thing you need to do for this. Not this one, not this one at this time. Okay? So I hope this video is helpful for you. Thank you.